So in this series, I want to do something a little different, something I haven't done before. I want to walk you through my preparation of some assignments for a class I'm teaching this fall. So this fall, I get to teach computational research methods. This is a sophomore level class. You just have to have our intro, physics 1, and basically we go further into using VPython to do numerical studies. It's intended for physics majors. I do occasionally get an engineering student who really wants to learn more. And this is going to be the first year that I use Jupyter Notebooks for this. So this is an opportunity for me to learn a little bit more about Jupyter Notebooks. I've made some trial notebooks so far, so I do know what I'm doing. But what I want to do is give the students for each major project a notebook for them to sort of start with and then develop. So what I want to do in this series is each episode I want to develop one of these notebooks. So I've got my schedule of topics here in my super secret Let's Code Physics video schedule. So today is an intro. So what I think I'm going to do is just kind of start each of these and kind of get some of their learning objectives written out. So if you are a physics instructor, this will be of use to you because it'll walk you through kind of the process of creating a template for students. I'll also have these files available to download in the description below of each video. And if you're one of my students, you can get an insight into what I'm expecting from these assignments. I'm not going to solve the assignment for you, of course. But let's see here. Let's start with Euler-Cromer method. So the first thing we're going to do in class is have a little bit of a review and extension of the Euler-Cromer method. So here I've got Jupyter Notebooks open, and I'm going to create a notebook with a VPython kernel. I think that's the only way I've been able to get VPython to work in Jupyter so far, is to start in a VPython kernel. So this is going to be, let's change the title to Euler-Cromer method template. Let's call it project template, and we'll rename. And let's see here, let's give it a title. Let's go ahead and copy this from here, copy. And I believe you do a double hashtag to get, no, that's a comment apparently. Oh no, wait, excuse me, this is, I need to toggle this from code. So basically each cell can be code to, or markdown. And when you have markdown, you can just type text. If you do a double, actually it's just single hash. That will now give me, if I run this, a title. So there's the title. And let's have the students add your name and information here. Change this title to be something more descriptive. So I'm already getting ahead of myself because I want to make sure, Control Enter, that I start with some learning objectives, right? We have to start with what we want the students to learn before we start asking them to do things. So let's think about some learning objectives for this assignment. Learning objective 1. This will be their first Jupyter notebook, so it will be to learn how to use Jupyter Notebook as a project report. Of course, we'll do some kind of workshop or something on Jupyter Notebooks before that. But this is going to be how to use it as a project report. And so then here, I will need some instructions of getting started. So we'll worry about that later. Control Enter. And then I'm going to add, let's move. I'll add a cell below here. And then we'll have learning objective number 2. Learning objective 2. Obviously they need to edit and run code. So we'll then have our first code below here. First code here. And I'll take care of fleshing all this out in the actual video that'll come out next week. Let's see here. Then we're going to add another cell below that. We'll make it markdown. And let's see here. What do we want to have in here? Learning objective 3. We want to practice discussing the results, or discuss the results. Cool. And so that's kind of a teaser. That's to sort of get them ready to work with us. Now we need to move on to the actual Euler-Cromer method in another section here. So let's change this to markdown. Learning objective 4. We'll have this be, how do I want to say this? They will technically at this point have seen the Euler-Cromer method in their intro class, but I've learned that students don't really remember the Euler-Cromer method, even though they use it all the time. It's just sort of part of the background noise. So this will be, they need to do something to explain the Euler-Cromer method. Is explain the right word? How about explain the use of the Euler-Cromer method? Yeah. Anytime do you really want the student to explain the whole method, like derive it? I don't think so. I think you just want them to explain the use of it. And so then we add in another cell, that'll be code, and then here we'll have, I guess I don't need double hash marks there for these comments, do I? Here we'll have a simple ECM code. Okay. So as I'm looking back over this, I'm thinking about these first couple learning objectives, and I don't know that they fit into a project per se. You know what? It can. It can, now that I think about it. This needs to be part of the ECM project setup. There we go. Because I don't want them to do a worksheet up here, and then a worksheet down here, and then a worksheet down here. Yeah, explain the use of the Euler-Cromer method. Cool. And then we'll add another cell here. And then we want them to be able to, learning objective 5, we want them to be able to discuss results of the Euler-Cromer method. So this will need to include animation and graphs. So this part will require minimal editing on the part of the student. And then let's put that same thing up here. Copy, paste. This part will require minimal editing. Part section on the part of the student by the student. This part will require minimal editing by the student. There we go. And so we are building up both their understanding of what they're doing and their project. Okay. I think I'm happy with that. And then what we do, we come down to learning objective number 6. Learning objective 6. Copy and modify the Euler-Cromer code to solve a new problem. So in other words, up here we saw something like we do simple harmonic motion, something that they know the answer to, and then here we have them do something new. And this is where the problem will likely vary with the student. I currently only have one student registered for this course. I'm hoping to get at least one more. Otherwise, it'll be a very easygoing class if I've only got the one student. This problem will likely vary with the student. And so then here, we'll have an empty code space. This cell will be empty, requiring the student to copy and paste and modify and run. And then we need to have repeat, I guess we'll call it learning objective 4 prime. Is there a way to say that you're doing the same learning objective twice, just expanding it? I don't know. Learning objective 4 prime, 5 prime. Discuss the results of the Euler-Cromer method. If I use this thing all the time, you would think I should be able to spell it. I forgot to change this markdown. There we go. Oh, good. It preserves the text. So really, I've got 5 learning objectives in this one activity. I've got learn how to use Jupyter Notebook as a project report, which is the whole thing, right? I mean, that is the learning objective for the whole thing. Learning objective 2, edit and run code. So here they have a simple first code. This will be part of the setup. So this is where we'll put in like the mass or something. For example, mass, initial velocity, things like that. So maybe I put the initial conditions in here. This is why I love like building this out with learning objectives, because I'm basically writing the assignment just by going over multiple passes. Learning objective 3, discuss the results. Okay, so that actually doesn't make sense now, because this is just going to be minimal editing by the student. So actually, I don't need this cell anymore. Cell edit, delete cell, there it is. All right, so this can actually become learning objective 3. They explain the use of the Euler-Cromer method below. Simple ECM code. So this is now objective 4. This is now objective 5. And so this is now objective 4 prime, like I had before. I knew what I needed to change, I just didn't know why. Okay, so we're talking 5 learning objectives, one of which is the assignment as a whole, one of which is a very basic review of editing and running code, and this will have include print statements to confirm. This one reviews the particular topic, which we'll have discussed in class, and I'll have them watch the Euler-Cromer for Beginners video. Simple ECM code, discuss the results, so did the ball bounce back and forth. Copy and modify to solve a new problem. The problem, force, will likely vary with the student. And what I think I'm going to do, I was thinking about this last night, I think this will involve implementing a force that permits scattering states and bound states and asking to change from scattering to produce scattering, both scattering and bound. Or is that a bit much? I feel like that's a bit much for the first assignment. So yeah. Let's have it, and as they produce one of two, evaluate the state produced. So then the next assignment, next project, will require comparing them. And I think that's actually a good transition over to the second assignment. The next topic is going to be the Runge-Kutta Method, which is a nice extension from Euler-Cromer. So basically we'll go right from Euler-Cromer to Runge-Kutta. Paste. Except this is no longer Euler-Cromer. This is now Runge-Kutta. There we go. Cancel. Okay, cool. And so I need to give this thing a name as well. Control A, Control C. Change this to Markdown. Control V. Runge-Kutta Method Project Template. Change this title to something more descriptive. All right, let's add a cell. All right, what is the first learning objective here, Brian? Well, if I compare it to this, I don't need these first two anymore, but I do need them to explain the use. Actually, let's do it this way. Let's have it learning objective 1. Compare the steps of the Euler-Cromer method with the Runge-Kutta method, or with those of the Runge-Kutta method. And basically what I'm going to do is have another cell down here. And basically what I'll do is I'll tell them to copy and paste your previous Euler-Cromer method code here. Because what I'm thinking is they'll copy and paste that, and then we'll have a, let's see here. We'll have another cell. We'll have Runge-Kutta code here. Change force to match that from your Euler-Cromer method code. And then what I want to do is add a new cell. The reason I want both of those is I want them to make a comparison. So learning objective 2. Compare the results of the ECM and RK4. Which is more accurate? Why? Well, actually, I guess they can't quite tell which is more accurate. Yeah, compare the results of the ECM and the RK4. Cool. So they'll have to discuss that here. I'll make up some instructions for them, maybe some questions. And then here they'll have to compare the results of the ECM and the RK4. And they'll add another cell down here, because now we move on to the next learning objective. Now we're going to start expanding on the physics. Learning objective 3. Adjust the initial conditions using the, in the RK4 code to produce a bound state and a scattering state. Well, you're not going to produce them at the same time. How do I word that? In adjusting additional conditions to produce a bounce... until finding a set that produces a bound state and a set that produces a scattering state. There we go. And now we're saying you're going to end up with two answers to this basically. And one's going to be a bound state and one is going to be a scattering state. I like it. Okay, and so then here we need to have another cell that'll be Runge-Kutta code here. And then we need to discuss the results. So learning objective number 4. Learning objective 4, discuss the differences between these states and the conditions that produce them. It would be nice if they figured out what the difference was. Identify or propose a possible distinguishing feature. Propose, how do I want to say this? Propose definitive distinguishing features between the two. All right, so this is numerical integration project template. I'm not going to tell them to adjust it because I should do that now. Numerical integration project template. I keep forgetting to change the first. It seems like the first thing should be marked down, but I guess you really want to get into the coding, huh? All right, so what are the learning objectives for numerical integration? Learning objective 1. Identify... Oh, I know what I'll do. Describe the differences between two methods of numerical integration. And I'll let them pick which two they want. Students pick which two. Left-hand sum / right-hand sum, midpoint, trap, well, I guess Simpsons is a combination of midpoint and trap, so that's not really fair. Monte Carlo. So they have 4 options. Pick 2 from 4 options. There we go. And again, I'll have them watch the numerical integrations video. That's why I've been pushing out all these tutorial videos. It's for my class. Let's see here. So then the students have to identify which codes to copy and paste in. Paste in the first selected method. And then they have another cell below that that is paste. You don't need paste in, Brian. Paste the second selected method. I want them to discuss the methods up here, and I want them to discuss the results down here. How do I say that? Between the... the steps of 2 methods of numerical integration. I'll probably find a better word later. Add a cell. Make it marked down. And now I think I'll do learning objective 2. Learning objective 2. Describe the differences between the results of the 2 methods when evaluating the same integral. There we go. Okay, and then we'll have another one here. We'll have learning objective 3. Describe the improvement of accuracy in each method. Got my mark down again. I saw that green in. Describe the improvement of accuracy in each method when you increase, when you decrease the step size. And so they'll have to have a graph for this. Use a graph to describe the improvement of accuracy, because on these two, the graph is going to automatically be included for them in the code. They just have to copy and paste it. But this one, they're going to have to figure out how to make their own graph for it, right? Because they're going to need, let me show you my new favorite tool here. This is Epic Pen. My brother showed it to me. They're going to have the answer versus n, the number of data points, and they're going to have to show me that it looks like this and that they're leveling out to some value here. So I think that's going to be pretty cool. Let me clear my Epic Pen. There we go. Let's see. I think that's good because one of the things that I like to try to make sure I do when I go through projects like this is eventually trim down the number of learning objectives and make them bigger learning objectives. So like there's 5.5 learning objectives here, but some of them are small, like press Control Enter in this code, you know. This one there's 4 and this one there's 3, and these are pretty chunky, right? Because this one's involving 2 methods and a comparison, this one's involving 2 methods and a comparison. They're having to do the editing on their own. Interpolation project template. Control A, Control C. And let's see. And since this is a research methods class, these projects take the place of an exam. Like, I'm not going to have a final exam where you come in and answer a bunch of questions about how to code physics. That would be a little silly. I think it would be silly. If you give an exam in your computational methods course, please let me know. I'd love to see it. I'd love to see what you can do with an exam. But to me, this is a research-based course. It needs to be with a bunch of projects. So let's see here. Interpolation. What do I need to do? I need to give them a data set. Give these students a data set. Well, one thing I want them to do is I want them to be able to evaluate the options. So let's say learning objective 1 should be to describe their goals for interpolating this data set. So actually, I'm going to need a cell in between there. So let's move this cell down. And then we'll add a cell here. Turn this one into Markdown. Give the students a data set. Data set goes here. Might come from, what do we teach in the fall? I think we teach modern physics in the fall. Might come from modern physics lab. It's a good idea. Learning objective 1, describe their goals for interpolating this data set. All right, and then learning objective 2 is going to be select an interpolation method based on the goal, based on the stated goal. Right? So we're moving here. Here I'm giving them a method and saying use this method. Here with Runge-Kutta, I'm giving them 2 methods and saying compare these. Here with numerical integration, I'm letting them pick 2 methods and telling them to compare them. And here I'm giving them the gamut of methods and saying, you pick the one that you think is best. Oh, I like this. I like this scaffolding that I've got going on between one assignment to the next. I like this. So let's see here. Explain why. Or explain how this method will meet the goal. Okay? And it might or might not meet the goal. It's okay to be wrong. I should put that here. Also, it's okay to be wrong. Okay? And so then here, we need to actually use the method. All right? So there's a lot more writing going on here before they get to the code. Right here, it's code, write, code, write, code, write. Here, it's code, write, code. Here, it's more writing. Here, it's a lot of writing before we get to the code. I like this. I like where this is going. Learning objective 3. Use the selected interpolation method to interpolate the data set. And so then we tell the student, you need to copy and pass it, interpolation method here. And then what they got to do is they need to first have markdown, and then learning objective 4. Assess, or evaluate, evaluate is better. Evaluate Evaluate how well method meets the goal. There we go. Yeah, I like how, well, this one's the shortest of all, but this has 2 things in there. Yeah, I feel like the assignments are getting shorter in terms of the stuff that's going to go in, but they're getting more complicated in terms of the stuff that has to go on in a student's mind. All right, what is up next? Finite differences. Okay, I'm actually going to have to wait on this one because I haven't finished recording my finite differences series yet. By the time this video goes up, this intro, I won't even have started, they won't even have started on the channel yet. So I'm actually going to wait to outline that one. Not outlined yet until I get more of that series recorded, because I'm going to have to be refreshed on like what the steps are, what the cognitive steps are along the way to being able to use finite differences. And then in the last video in the series, I'm going to make adjustments, because what I would love to have, and thank you for sticking with me on this long video, what I would love to have in each of these videos, I would love to hear your comments. If you're an instructor and you have done something like this and you think I've made a mistake, please let me know. If you're a student and I've done something that seems to not make sense, please also let me know. And then basically in that last video in the series, I'm going to go back over these and make some adjustments. So thank you so much for watching. Thank you for the feedback that you are now typing furiously into the comments below. I will see you next time. Bye-bye.